Uh, Greetings from Silver Spring, Maryland. My name is Mark Czarnolewski. I'll be talking about the Everyday Spatial Behavioral Questionnaire, a project I've been involved for over a quarter of a century, and I'd be remiss if I did not mention co-investigators at different times. John Elliott, who started it, and at the same time as John Elliott, Thomas Rio and Deborah Stone helped with the first version of the EBQ. And then Carol Lampton came in at about 2013, and we developed the second version of the EBQ. As a map for this presentation, big theme for those studying navigation, there are three stages of development of the EBQ that will be presented, some more than others. Stage one was the first EBQ. We'll discuss the initial item development, initial scale development, how we were able to develop reliability even with limited responses, how we established construct validity through canonical. Stage two was when you had access to many more subjects than in stage one. So we were able to use principal components for over the 100 plus, by this stage, 132 items in the analyses, and we had over 700 plus subjects to do that. And there was scale refinement, and we'll go into that. And stage three is the measurement invariance testing, which includes how I developed them, how I use measurement invariance testing to validate and test the generalizability of the EBQ. So right now, the EBQ can be considered a reliable research instrument for measuring self-rated difficulty performing common activities hypothesized to entail spatial thinking. Provide the framework for understanding situations that differ in terms of type and scale. We established its statistical validity through measurement invariance testing, first through principal components to categorize the items, and then measurement invariance testing to test the generalizability between two large samples. Again, these are self-ratings, not based on observation of behavior, and the measurement invariance testing was done through diagonally weighted least squares because these behaviors of everyday these particular behaviors of everyday activity are skewed. And how do you deal with skewed data? Not with the typical maximum likelihood testing. And the first version of the EBQ, we established times direct validity, and we'll go into that. And why validate the EBQ model? Because we have scales that people can self-evaluate themselves in terms of different activities involved in distant area estimation, navigation, fitting items, driving, and many more items. Here are the scales of the EBQ, and with example behaviors for each. There are 11 presented, i.e. 11-component model, and we'll go into how they were developed in a few minutes. Going back in history, 1998. This is the initial scale for the EBQ. Now, the left side where subjects can rate the activity that's along the left side of the questionnaire, whether it was rarely difficult to do or up to almost always, or during the past 12 months. We did not want to tax memory. Back then, that was the thought. And if people did not do the activity the past 12 months, we offered them the opportunity to say why. And those checks on the right were recoded so we could get more data, more subject responses. This is the current version of the EBQ. Notice those free right scales or choices are not there. We're focusing on whether the activity is difficult or not. We're not limiting it to the past year, but not everybody does all 132 behaviors within the year. So we were losing data, and not only losing data, even if we recoded the data, we knew we're dealing with compromised reliability estimates. How does this whole thing develop? Answer: from scratch. And John Elliott had had conceptualized spatial intelligence with prior researchers, estimating size, position, distance, direction of objects of everyday behavior, for example, which fit different everyday behaviors. And we categorize the behaviors. We had to generate the behaviors, or i.e. activities, as you saw just recently, prior scales. And then we had to pilot test. Pilot test means we went out to different classrooms, John Elliott's choir at his church, and pilot testing to get some initial reliability estimates. And based on those estimates, we were able to run Spearman-Brown prophecy formula to see how many additional items to get reasonable reliability for a research instrument. Again, research instrument. So it was content validity based. These are the scales from Elliott and Czarnolewski that were concretized or developed back in the first version of the EBQ. People estimating object capacity. For example, how much stuff to put into a suitcase, what would fit? That's not something paper and pencil test asks, and yet we all have a sense that involves spatial skills. Driving, that we have a better sense that involves spatial skills, and putting things together, estimating direction, etc. Now, these for those back then 12 scales on the right, we have the Cronbach alphas, our reliability estimates. You'll also see that the number, it says number of items used for the number of items in the scale. Not every item was answered by 120 respondents. So we use only the scales, the items that were answered by 120 respondents. And with list-wide deletion, you got even fewer subjects. So this number of subjects that was used to estimate these Cronbach alphas, and you could see for even these number of subjects, there was at least a 6 to 7 to 1 ratio between subjects to items to get some semi-reliability. Validity. We use canonical correlation. Canonical correlation is something that's not talked about too much nowadays, but was talked about somewhat back in the year 2000. And basically, in canonical, you have a set of criterion measures and a set of predictor measures. You develop a best fit line among the criterion measures, another best fit line among the predictors, and the two best fit lines, you develop a best fit line between the two best fit lines. And the model that was the most robust is what I call the main effects model, and we were able to explain 34.7% of the variance. It's the square of the canonical correlation. Nice and Kraber and Nicewater strongly suggested over other approaches. And we were able to, this model of what, this variance of what I'm going to be presenting is what's common between predictors and criteria for the two latent characteristic roots. And here we see we have spatial scale and driving loading on the same characteristic root as hidden figures, age, and gender. And here we have another characteristic root of estimating direction, reversals, driving, drawing, etc. And we have two spatial tests, two of the 5 included in the model, mazes and hidden figures loading on the same items. Scales. Well, we had to redevelop the EBQ, and we were able, when we redeveloped it, we had more than enough subjects. We dealt with outliers, response bias, whatever. Sample 1 had 726 subjects, sample 2, 772 subjects. And in measurement and variance testing, that we use 3 indicators. The idea is, as you go through the 4 critical steps, that the change between each succeeding step doesn't decrease more than 0.01, doesn't come close to it, and or it doesn't increase by more than 0.015. Again, doesn't come close to it. It's 0.001. What do those things mean? We've established that the number of loadings on each factor are the same between the 2 samples. We've established the latent constructs have the same meaning. The factor scores in one sample are equivalent to the factor scores in the other, and residual variance, or variance not explained by items and factors, are equivalent in both samples. And again, here are the scales. Here's a close-up of items with 3 of the scales and their respective loadings. And reliability, as you can see for the 11-component model, is pretty high. It's lower for certain items, for certain subscales that require a relook at. Sample 1 had higher reliabilities than sample 2, and it was higher than the 9-factor model also considered. There are gender differences in the expected directions. Navigation, guys find less difficult. find driving less difficult. Females find dancing less difficult, and targeting guys find less difficult. If you think of that crumpled piece of paper in the wastebasket, that's one of the items. So we relied on Prague from Neuropsych to help develop items, and lo and behold, the items that we generated overlap with items from the neuropsychology literature, hitting a nail, catching a ball, grasping, reaching, etc. These behaviors are overlap with both the EBQ and with the neuropsych literature. And that, ladies and gentlemen, is it.
16 minutes.
Thank you.
At this point, you would, in the small menu at the top of the page, click the 3 dots more and select pause or stop recording.
Anyway,
and select stop
hold
from
on.
those two.
More. Okay. Select.
Pause or stop.
Pause or stop. Do you see it, Michael?
The top of the list.
Pause or stop. Duh.
And then
Where do I click?
moves.
Pause or stop?
Stop.